division. We're going to put numbers up here. We're going to multiply them together. We're going to subtract, bring down the next number, do it all over again. That's long division. We're going to learn it, and then we're going to keep it in our toolbox, but we're not going to use it as much as synthetic division. Y'all, what does synthetic mean? Yeah. So we're going to do some cheat. It's not real math at all. That's on the back of the page that you're on right now. To do synthetic division, I draw an upside down division box, and then we'll just work it that way. Most of the things that we use division for will be synthetic. Every once in a while, you're supposed to be seeing this. Yes, ma'am. Every once in a while, we are going to use synthetic. Every once in a while, we're going to use long division. I don't know what's wrong with this. I hit something weird.
Oh, there you go.
Sorry. Y'all see my hand? Yeah. Okay. All right, so let's get started. On your problem 1A, will you please write it in long division form like this? If you notice, it is your factor problem, so we're going to check to see if you factored correctly. Okay, a couple of things that we need to remember. That X right there drives. He's a driver. He's going to drive the whole entire problem. He's going to drive what the answer is. He's going to drive what you're going to write on your paper. Everything else is just along for the ride. The -4 doesn't matter. This stuff in here doesn't matter. This is the only thing that matters. So here's what we're going to do. We want this X to look like that X. That's a single X, but this is 5X squared. What would you multiply this by to make it look like that?
5X.
Good. Let's keep all of our exponents in order. So a single 5X needs to go right above the -17X because they both have an exponent of 1. All right, now let's distribute. Let's multiply. 5X times X is 5X squared, which is exactly what we wanted. And then 5X times -4 is -20X. Put that right below the -17X. Now we're going to subtract, just like regular old elementary long division. But remember, look, I'm not just subtracting the 5X, I'm subtracting all of it. So we always distribute a negative when we subtract. So always change the signs when you get to this part of your long division. Always, always, always. All right, so I know I'm on the right track because my first terms cancel. They always cancel. If they don't cancel, I did something wrong. But they cancel, so I'm good. So now we're going to have a -17X and a +20X. That's going to be a 3X. And then don't forget to bring down the next term. Go back to the driver. So this X, now it wants to look like 3X. So what would we multiply by? Yes, a +3. Let's write +3 up here. And then let's go ahead and do the work. 3 times X is 3X. 3 times a -4 is a -12. Y'all, what's going to happen when we change the signs? That's so beautiful. It all wipes out to a 0, but that makes me so happy. Just drawing a 0 is not enough to show how happy I am. It means so much to me that there's no remainder. The reason why it means so much to me that there's no remainder is because I found factors. Guys, when you factored this on your warm-up, you should have got X - 4 and 5X + 3. If you had time, I know we had a drill, maybe you didn't have time. So these are both factors of 5X squared minus 17X minus 12. And I know they're factors because I didn't have a remainder. So this week, we're just practicing long division and synthetic division. Next week, you're going to have this in your toolkit to do the bigger problem. Okay, just want to remind you guys, no remainder. One more thing. Please remember that that's the quotient. Remember, quotient is a fancy word that means the answer to a division problem. Yay, no remainder. Let's do it again. Let's look at letter B. So for letter B, I have already written it in long division form. So we copy it like this. And then let's go back to the driver. So remember, your driver is 3x. We want the 3x to look like 6x cubed. What do you multiply by? 2x squared. Awesome. Let's put that right above the quadratic term. Let's distribute. 2x squared times 3x is 6x to the third, exactly what we wanted. 2x squared times a negative 2, don't forget that's negative 4x squared. But it's not staying negative for long. Remember, we have to change the signs and combine straight down. So when we combine straight down, our first terms go away, thank goodness, or else we did something wrong. Negative 16 and a positive 4 is going to be a negative 12. Negative 12x squared. Don't forget to bring down the next term. So let's write plus 17x next to that. Go back to the driver, start all over. This time we want positive 3x to look like negative 12x squared. So we're going to multiply by, yes, negative 4x. Put that right above that 17x. Distribute. So negative 4x times a 3x is a negative 12x squared. And then negative 4x times negative 2, y'all, that's a positive 8x. But again, those signs are not staying like that for too much longer. Let's go ahead and change the signs and combine straight down. Okay, those go away. That's a zero pair. Yay for us. Positive 17 minus 8, that's going to be 9x. We've got one more number to bring down, so we've got to do it one more time. Let's write minus 6 to that. And then how can we make that 3x look like a 9x? 3. Plus 3, yes, right, a plus 3. Y'all, look what happens when we distribute. Aren't we so happy? We are so happy. You think I'm joking. I know what's happening next week. No remainder. Yay. So please remember, that's your quotient up there. But since I did not have a remainder, I can also call that a factor. What else can I call a factor? This one. That's also a factor because of no remainder. That's how important it is. There's no remainder. Okay. Let's look at letter C. Uh-oh. So I started drawing the division box for letter C, and then I got stuck. Y'all, highlight letter C. There are two things we need to talk about on letter C. All right. First of all, on letter C, notice how this is greater than the power of 1. Y'all, when it's greater than the power of 1, it's long division only. I cannot go fake on a higher degree. Also, guys, if you notice, that polynomial did not have a cubic term. So all degrees. must be represented. So y'all, we have to put a little placeholder right here. Okay, now we are ready to just let this drive the whole problem. So we want x squared to look like x to the 4th. So we're going to multiply this by plane x squared. Make sure you line up your degrees. And then x squared times x squared is exactly what we wanted, x to the 4th. Don't forget you got to distribute it to the -3. So x squared times the -3 is a -3x squared. Y'all look at all this space. Make sure you keep everything lined up. Okay, let's go ahead and change those signs. We're ready to combine straight down. That's a 0 pair. That 0 is just a placeholder. So we're just going to combine a positive 4x squared and a positive 3x squared. So let's write 7x squared. Bring down that next number. And let's start all over. Go back to the driver. So this time we want x squared to look like 7x squared. So we're just going to multiply by a 7. So put plus 7 above the -12. Put it way over here. All right, let's go ahead and distribute. Look, when you do a positive 7 times a -3, that's a -21. Look, I skipped more space. It's so important that everything lines up. Let's change the sign and analyze what happens here. Okay, so the x squareds go away. Perfect. Y'all, there was nothing that canceled out this -3x. So we have to bring this down. And then look, I have a positive 21. I would write that right here, but remember when you divide, you would bring down the next term. We're going to combine these constants. We're going to have a remainder. So this is our remainder, -3x plus 9. There's no way I can keep going because that degree is higher than that degree. So we stop. We have a remainder. Y'all look, the quotient doesn't look like this when you have a remainder. When you have a remainder, the quotient is going to have a plus with a fraction. When you have a remainder, your quotient has a fraction with it. The fraction's numerator is the actual remainder, so we copy -3x plus 9 on top. The denominator is the divisor. So let's copy this underneath. So this is the quotient. Any questions on letter C? Letter D. Y'all, letter D is not too hard. It has a lot of missing degrees. Just put your placeholders there. So just draw it like normal. You're going to have a couple of zeros. Y'all, I just want to remind you it has a degree of 2, long division only. All right, well, let's keep going. I think this one has a remainder, so it's sad. Let's see, x squared, we want it to be x to the 3rd. We're going to multiply by an x. All right, so x times x squared is x to the 3rd, which is what we wanted. And then, y'all, don't forget we have to multiply by that 1. So put plus x all in line. Let's change the signs. All right, so those go away. These terms go away. There was nothing there anyway. But look, you have 0x minus x. So let's write minus x. and bring down the next term, which is minus 9. And then that's it. We cannot keep going. That's your remainder. I told you it was a sad problem. Please remember your quotient is going to have a plus sign with negative x minus 9 on top, x squared plus 1 at the bottom. Now look, I hear you flipping pages. You can flip, but y'all look, I want to show you something at the bottom of my paper. We're about to do fake. But before we do fake, fake doesn't work for everything. I just want to show you what you have to use long division for. You have to use long division for stuff like that. Any power greater than 1, you have to use long division for. Also, if you are dividing by a power with 1, but you have a number in front. If you have a number in front of a single x, you have to use long division. And guys, we're not doing it in this class, but you can also divide by any trinomial you want. So if you're dividing by more than 2 terms, long division is the only way to go. Y'all, here's where we get to use the fake. Stuff like this. Just little baby monomials, no number in the front, no higher exponent. This is ideal for synthetic division, and this is truly what we're going to be looking at next week. This week, we're just getting solid on the skill. Up here? No, if you got a plus sign, you're good. Yeah. No, I'm just showing the placeholders. Yeah, if you're good, you don't have to do that. He asked a really good question. He asked, do I need to show these zeros? And I'm like, no. But Ian, on synthetic, yes. You totally need the zeros on synthetic. All right, let's go ahead and talk about synthetic. Yay, synthetic. We love fake stuff. We really love fake stuff. All right, look. Here's the deal about synthetic division. It is always opposite on the divisor. Y'all see this x plus 3 right here? We're going to be using a negative 3. And we love synthetic division because we are really in the business of finding factors. And this is going to help us. How do I know if it's a factor? If I do not have a remainder. All right, so it is fake. So I'm drawing an upside down division box because it's fun. And then see this x plus 3? What's the opposite of positive 3? Negative 3. That's going out here. We're going to fit 2 rows of numbers in the upside down division box. The first row are the coefficients right here. And guys, as I was moving my finger across here, I was making sure all of the degrees were represented, which they are. So we can go in order also. It's already in descending order. So let's copy this 5 right here. Let's copy the 18 a little space away from it. We're only concerned about the coefficients. Let's write a 7, and then let's write a negative 6. All right, so here's how you do this fake stuff. You always bring down the first number, and then you multiply it. We're going to multiply a negative 3 times that first number. What's negative 3 times 5? Negative 15. Yes, that goes on the second row. Then you repeat over, combine straight down. What's 18 minus 15? Negative 3 times positive 3, negative 9. Put it in that next row, combine straight down. Combine straight down with a negative 2. What's a negative 3 times a negative 2? Oh my goodness, we're so happy. You guys think I'm joking. One problem next week will fill up an entire sheet of notebook paper. It is so much happiness right there, so much happiness. I got so happy I forgot to tell you how to write the answer. All right, here's how you write the answer. Remember, this started with an exponent of 3. Y'all, these are the coefficients, but it's going to start with an exponent of 2. So the quotient is going to be 5x squared plus 3x minus 2. Yay, yay, yay. No remainder. I can also call this quotient a factor. Yay for us. I can also call x plus 3 a factor. Yay for us. Because that's what we care about. All right, let's go ahead and take a look at letter B. All right, so for letter B, guys, I already wrote it upside down, but my numbers are not in the number order for the other one. Look at the packet. Why are my numbers in different order in my division box? Yeah, because of degree. Good job. All right, let's bring down this 9 and just start the process, y'all. I already hear pencils on paper, so I need to get caught up. 2 times 9 is 18. That's a 0. That's okay. 2 times 0 is 0. Negative 16 plus nothing is negative 16. Oh my goodness. Oh my goodness. I'm so happy over here. Negative 2 times, or positive 2 times the negative 36 just makes me so happy because there's no remainder, y'all. So we know x minus 2 is a factor. We know 9x squared, there's no linear term, so it's just 9x squared minus 16 is a factor. We also know that 9x squared minus 16 is the quotient. Look, let's keep going on this factor. Do y'all recognize what this is? This is a difference of 2 squares. What is this factor to? 3x minus 4, then what? 3x plus 4. I am just going to draw a heart around that because that is just happiness right there. All right, y'all, let's keep going. Letter C. All right, will you highlight letter C? Now, if you remember, I told you you could not do synthetic division when you had a number in front of x. Come on now. You're not supposed to use synthetic division, but I'm going to show you how to cheat. Take it or leave it. I'm going to show you a way to do this. If you slide and divide, if you factor like I do, then you should be all right with this. All right, let me show you what's going on. This 5x plus 6, by the way, it only works with the exponent of 1. If that was 5x squared, I'd be forced to do long division. But it's to the power of 1, so I can cheat a little bit. Y'all, let's solve for x. Let's set that equal to 0 and solve for x. What is that going to be? Yeah, what happens when I move this positive 6 over here? Yes. So, when you have a number in front, solve for x, and then you take that straight over there and copy it on the outside of your division box.
Did you say that there's a number in front, but there's no just do long division?
You can. I'm just going to show you a different way to do it. You can choose any way you want to do it. All right, so when I put a negative 6 over 5 right here, I'm ready to divide. Let's bring down the first number. Oh, look at this. This reminds me of our warm-up. What is a negative 6 over 5 times 5? Negative 6. These 5's cancel. Let's write negative 6 right here. What is a positive 11 and a negative 6? A 5. What is negative 6 over 5 times 5? What happens? Another negative 6. What's 26 minus 6? Y'all better be careful. What's negative 6 times 20 divided by 5? Or what's 20 divided by 5 times the negative 6? Negative 24. That's right. Thank you. It's about time somebody else recognizes how special that is. All right, look. Here's the deal, y'all. And this is cheating. See how this is divided by 5? You got to go back and divide all these by 5. So if you want to use this method, knock yourself out, but you got to remember to do this step. Because y'all, you got to divide, because this is the quotient. 5 divided by 5 is 1. It's going to be x squared. Remember, it started to the third power. It's going to start with 1 less. 5 divided by 5 is your single x. Your constant, 20 divided by 5, is 4. This is the quotient. You got to remember to divide by 5.